Hey everybody, what's up? Stingray here again, and welcome to episode number 5 of my Devlog series on my Sandbox game. This will be a pretty big episode. We will talk about infinite worlds, we'll talk about dynamic chunk loading, we will talk about a whole new terrain generation system, we'll talk about cave gen, kind of, and we'll even talk about modability, because that is a thing, or will be a thing. But it's relevant for today, so I'm gonna talk about it. So with that said, let's hop into it. Alrighty, so here we are in this now very much infinite world. So if I just fly over to the edge of the loaded chunks over here, you will be able to see that it starts generating more terrain, as you would expect from infinite worlds. The way it works is actually very simple. It just takes a certain area around the player defined by the render distance and just loads those chunks. In this case, for demonstration purposes, it's only set to 2 chunks, which means it'll load a 5x5x5 chunk area around the player. You can see that when I actually move away from an area, it actually keeps loaded a much larger area. This is what I call the unloading tolerance, which basically just means that a chunk gets loaded when it gets within the render distance of the player. Again, that 5x5x5 chunk area in this demonstration purposes, in this demonstration version, that way around. But a chunk stays loaded for much longer, as in the chunk can be much further away and still stay loaded. In this case, the unloading tolerance is 8 blocks added to the 2-block render distance here, meaning that it actually keeps loaded a 21 by 21 chunk area, or actually 21 by 21 by 21, because keep in mind we have a 3D chunk system here, so we're actually keeping a 21 by 21 by 21 chunk area loaded around the player. Also, one thing that's worth noting here is that Minecraft world 256 blocks high is actually an equivalent of 16 chunks high. So the area that stays loaded by this game is already higher than Minecraft's entire world is high, which, you know, I think is pretty crazy. Okay, so if I fly over the edge here, you can see that the terrain generation is actually pretty slow. And the reason for that is that it's simply not very well optimized yet. The main thing that I can do here is just making the whole thing asynchronous, effectively, you know, letting it run on more than one CPU core. Actually, that goes for the terrain generation, because the main thing that actually slows this down is the mesh generation that has to be done on all the generated chunks. So the mesh generation, with that I can actually go even further, and instead of saying I let it run on multiple CPU cores, I can even go ahead and use computational shaders, effectively letting the whole logic for the mesh generation run on the graphics card. Because in the end, you have like 4,000 blocks in a chunk, and you have to do the exact same logic for every single block. And that's just a task that is very, like, it's made to be run on the graphics card. So that's definitely one thing that I'm gonna look into. But this whole optimization is a thing for the future in general, because it's just not a priority right now. But of course, in the long run, it is very important. Another very quick thing, not quick to implement, but a quick thing to explain, I guess, is that this chunk loading has to just be more intelligent. Right now, it just generates the chunks as they come in a sense, but a more intelligent system would always try to load the chunks around the player first, right? Like the closer a chunk is to the player, the higher its priority is to be loaded. And, you know, that's just another thing that on top of just increasing the efficiency. Okay, we are now in a slightly different version of the game, which you might notice looks a little bit different than the other version. I've made this version specifically to showcase the new terrain generation system, because while the old terrain generation system was really just like very improvised just so that I have some terrain, with the new world system, or with the new infinite world system, it was now time to actually have a proper world generation system in place. And I'm not talking about the generation logic that actually sets the blocks or anything. I'm talking about the fundamental architecture that allows the whole thing to happen. Because the previous improvised version was really just do stuff in this area and that's it. But now I had to do this chunk-based, which sounds easy enough at first, until you recognize that chunk-based generation comes with its own problems. Specifically, artifacts that can happen from offset block checks. What those are is actually pretty simple. If you take a look at this code from the overlay generation, you will notice that for every block, it will take a look at the block above and see if that is an air block. If yes, set it to grass. If no, check the blocks 2 and 3 blocks above, if those are an air block, and if yes, set the block to dirt. That's the very simple terrain overlay generation, and it checks blocks that are not the block that I'm setting. That is an offset block check. And the problem with offset block checks is that those blocks that you're checking might be in a different chunk, which causes problems if that chunk is not yet loaded. So what can happen with the overlay is that it actually generates overlay in the middle of some rock because the chunk above is not loaded, so the world generator sees air when it checks the blocks. And to remedy this problem, I built a staged generation system. So what happens is there are different generation stages. The first one will be the relief that just creates the height of the terrain. The second one will be the overlay, which we just actually saw. And the third one in this case will be the cave generation. And for a chunk to generate to a certain stage, itself and all of its 26 neighbors, keep in mind 3D, all of its 26 neighbors and itself have to be loaded to have to be generated to the stage before. So here we can actually see it in action. Those chunks over there, these stone chunks, are generated to stage 1, just the relief, right? It just takes this noise value, and anything below this noise value is stone, anything above is air, simply enough. Then we get the overlay over here, and then we get the cave generation here. So if I actually fly into this direction, you can see that it actually starts to generate chunks to new stages, right? So we can fly here as well, and you will be able to see that over here it will actually now generate a cave. Because, you know, the cave generation says generate a cave there. But those chunks over there, for example, are now still only generated to stage 2, which is the overlay. But stage 3 is not yet generated. If I fly closer, then this actually gets generated to stage 3, which in the current stage is final stage, right? In the current state of development. So yeah, this is basically how that works. It was a bit of a pain to implement, but in the end it's not actually that complex of a concept. It was just mostly an optimization thing to get everything to work properly. But this actually now allows me to avoid these artifacts by making sure that every chunk around a chunk that I want to generate is at least the stage below the stage that I want to generate. I can basically guarantee that artifacts like these overlay generation inside of a solid chunk of rock doesn't happen anymore. And that's really cool. This is really powerful, and the system allows me to now very easily add new stages to the terrain generator whenever I want to add something to the terrain generation. And getting into the realm of modding for a little bit, which generally speaking is of course something for the future, but talking about modding, this whole system allows you as a modder to also relatively easily add new generation features, right? So you can just throw in a new stage and have it generate. You can also reuse stages for multiple worlds, for example, and things like that. So that's pretty nifty, I guess. Okay, one thing that I brushed over for basically the entire episode is, of course, the new terrain generation that you can see. that looks quite a bit different and, in my opinion, quite a bit better than the terrain generation before. The reason for that is, of course, simply that I changed the logic that generates the terrain. Keep in mind that basically everything that you see here is really just temporary, really just intended to demonstrate the technology. You know, basically the whole game at this point is mostly a tech demo at this stage, with no final features except for like block placing and block breaking. So all of the terrain will change quite drastically in the future. Of course, it will change properly once more blocks are added, but that's for the future as well. But I just want to very quickly go over what I've changed so far to get to where we are now. So for the relief, that is, you know, the height of the terrain. Previously, I was just using the Unity built-in Perlin noise to generate the height map, which, you know, worked fine just to have some terrain, but it honestly just doesn't look very good. So for the new terrain generation here, I switched to Fast Noise, which is a library that you can download. I'll link it in the description. It's open source, you can just download it and, you know, just use it in your projects. And I'm now actually using Simplex Noise, which is kind of like an improved version of Perlin Noise. And I'm actually using two layers of it. One relatively large layer that creates all of these larger mountains and valleys and all that kind of stuff. And then a very small coarse layer with a relatively small effect that then, you know, causes the whole terrain to not be too smooth. And that basically creates all these hills and valleys and just makes the whole terrain look quite a lot more interesting than just the smooth terrain that we had before. The overlay is still the overlay, nothing changed there, it's still the exact same logic. And of course the biggest change is, of course, the caves, because, well, we didn't have caves before and we do have them now. So the caves are actually at this point very simple. They are really just 3D simplex noise, and I'm just saying, okay, anything where the noise value exceeds a certain threshold is a cave, anything else is not a cave. Cut out the caves, done. At the moment, because I'm just using simplex noise, it currently creates these massive cavities that, you know, they look pretty cool, but they're not very easy to navigate and not exactly that survival friendly. And you just don't get these kind of cave corridors that you know from games like Minecraft. And to do that, I will have to look into Wall-E noise and stuff like that, but that's for the future, because again, this whole thing is just to demonstrate what I've been doing so far, or to demonstrate the technology. In the end, just changing out the 3D simplex noise for 3D Wall-E noise is, you know, just a change in the logic. Again, as I just mentioned, it's just switching out the logic of the generation stage, and that is it. Realistically, I will probably keep the simplex noise as well and just have that to generate large cavities to then connect with corridors generated by Wall-E noise. But again, that's all for the future. And for now we have this, which, you know, looks pretty cool, works well, and I'll just keep it for now until I actually get into proper terrain generation definition, I guess. So yeah, that is the end of the video, so thank you very much for watching. If you want to get more frequent, more detailed updates on the game, check out my Discord and Twitter, links are both in the description. And apart from that, don't forget to like, comment and subscribe if you like my content, and see you next time. Goodbye.